Hi, my name is Brittany Wenger. I'm a junior here at Duke, majoring in biology, and I created Cloud for Cancer, which is a program that uses artificial intelligence to improve breast cancer diagnostics to make them quicker, cheaper, and less invasive for patients. My little brother was born premature, and he spent like 60 days of his first year in the hospital. He's great now. He's actually like on a top soccer team. But at the time, I spent a lot of my early childhood around doctors, really growing to idolize the men and women in scrubs. I always kind of gravitated towards helping people, wanted to get involved in medicine. I'm an extrovert, definitely by nature, but I think I had maybe more alone time as a child to be putting together puzzles or questioning things. My parents were always they say I was like the kid who never outgrew the why phase, but they never did anything to stop the questions. They either tried to entertain them, or what's even better is when they didn't know an answer, they wouldn't try to make something up. So I took this futuristic thinking class, and the whole point was we would read these scenes that were written about as if they were 30 or 40 years in the future about what was happening in the world. And we would have to identify problems in the scenes and then come up with solutions. And I got really interested in artificial intelligence from just this is so cool standpoint, and I had read papers on it. And so at that point, I really wanted to be involved in actually creating the artificial intelligence. But the only way to do that is to code, and I had never coded before. Literally bought a textbook that was like, Learn to Code 101, and kind of started coding from that. So I taught the computer how to learn to diagnose breast cancer, and I did this by using by creating an artificial intelligence algorithm. So it's able to predict whether somebody will have cancer or not based on their sample. Even though I didn't have an MD or PhD, I think for me this was really a process of trial and error. And I was so curious and wanted to do this so badly that I just kind of persevered. And that's what's kind of beautiful about being a high school student. If it had flopped, there would have been no repercussions. Sure, I spent a lot of time on something that wouldn't have worked, but I have a lot of time left to do cool things. Running the Google Science Fair, everything was really a whirlwind. The next day I went into Google. I had 9 interviews within the span of 2.5 hours. But I kind of thought things would die down after that, and they just didn't. And I was for an entire year, I was really busy, and I was just so excited by how many people wanted to learn about my work and help me advance it further. I mean, I've given now 4 TED Talks, which is amazing. I've been to the White House now 3 times. Which is insane. I've met with leaders in Congress about how to get more women in STEM, and I got to talk to President Obama for 6 or 7 minutes about my research. There's a video of it somewhere online, and I'm completely shaking and just over the moon the entire time, but that was really an absolutely surreal experience that I got because of the Google Science Fair 100%. And I think what's been really cool about the whole thing is I've picked up some amazing mentors along the way. So there are scientists who have read my work and helped me edit how I'm presenting it, how I'm testing it to further refine Cloud for Cancer. I think for me it's really exciting to see my technology progress and move forward, but more importantly it's nice for the women to not have as invasive a procedure, to have it cost less, and to have it be quicker. So I think really it's more exciting to think of how this will change the field of breast cancer detection. But I also think that this sort of enhanced neural network model I've built has a lot of potential for other laboratory sort of questions because it's classifying things. At the end of the day, it doesn't know that it's just doing breast cancer. And with some pretty intense modifications, but modifications nonetheless, I was able to build a highly successful neural network for leukemia. It was able to see who had a genetic predisposition that would cause their leukemia to be more aggressive, and actually recommend potential candidate proteins for drug targeting, which is a completely different application than breast cancer. So I think continuing to get sort of the underlying model out there and used in other labs is also a really exciting future angle for this technology.